This is section 5.4, and we start out with log functions. A logarithm is an exponent. That's exactly what it is. So in other words, if you see log 1000, that represents the exponent k such that 10 to the k equals 1000. So what this is saying is, what number could 10 be raised to give you 1000? And that would be 3. If you look at your calculator, let's pull that over here and get out of the graphing and clear. There's a log button right here, and so if we hit log 1000 and close that, we hit enter and we should get 3. So it is an exponent. That's what we need to remember. Always with the base of 10. Okay? So if we have the common log, that's log x, there's an understood base of 10. All right. There's also what's called a natural log. That's ln x. It has a base of e. And if you look at your calculator, you have that one down here as well. That does not have a base of 10, has a base of e. So both of those are on there when we need them. So if we were evaluating log of 100, let me get my other pens. All right, so if I'm going to evaluate log of 100, that means 10, an understood 10, raised to what power gives me 100? And 10 squared gives you 100, so that evaluates to 2. 1 over 1,000, so 10 raised to what power is going to give me 1/1000th? And anytime you see a fraction like that, this is going to be a negative exponent. So 10 to the -3 is the same as 1 over 10 cubed, which is 1 over 1,000. So when you see the fractions, you're going to be talking negative exponents. All right, just a reminder here about going from radical to fractional exponents. The y, whatever is in the index, is the denominator of your fraction. This number, either inside or out here, would be the numerator. So if we have the cube root of x to the 4th, that's x to the 4/3. 5th root of y cubed, that'd be y to the 3/5. Okay, something important to remember, we cannot take the log of a negative number. That's going to be important when we talk about the domain of a log function. So you can't take the log of a negative number. If you were on your calculator and you said log -60, did that work? Hold on. Okay, when I scrolled over far enough, here's an I on the end, which means that's an imaginary number. So typically you would get an error. It's an imaginary number, so you wouldn't get no real number that is the log of a negative number. So that didn't work as well as I wanted, but it does give us that I. All right, let's see. Let's move up here. All right, now this is important. This form, log base a of y equals x. We need to know what the parts are. The a part is the base, so I've written it with numbers here. So 4 is the base. 3 over here is the exponent, because the log expression is the exponent. And the 64 we call the argument. Okay? So if we had log base 5 of 25 equals 2, and we wanted to rewrite it as exponential, this form is the exponential. This form is the log form. So base to exponent equals argument. Base to exponent equals argument. And then if you had the exponential first, 3 cubed equals 27. You have the log base 3 of 27 equals the exponent 3. All right, so you might be asked to go back and forth. These are important to remember. log base of the argument equals the exponent, base to the exponent equals the argument. And so if you had to go back and forth, those are good to have as a reference. Sometimes you'll be asked to find the log base 7 of a number. You can't do that on your calculator with just the log button because its base is 10. So here's a change of base formula. You can do log of the argument over log of the base. So let's look at this. Log base 4 of 64. We would do log 64 divided by log 4. You can do that on your calculator. You can do log 64, be sure you close, divided by log 4. And you get 3, and that makes sense. 4 to the third power equals 64. All right. Next part here is about the domain of a log, and remember we said the argument, this thing that we're going to take the log of, has to be positive. So you take that piece inside here, set it greater than 0, and solve it. So in this case, we would subtract the 3, and we get x is greater than -3. That's the domain. Let's look at that in the calculator. Let's put log of x plus 3, and I don't need this 11 million. Clear that out. And let's do a zoom 6. All right, so this graph starts here and goes forever this way. And if we zoom in on that, zoom 4, you can see that -1, -2, -3 is where it starts. It does not exist over here. X has to be greater than -3. All right, so that's what it would look like graphically. All right, if you're solving base 10 equations, so here's what you start with. 4 times 10 to the 3x equals 244. First thing, isolate this expression. So divide both sides by 4. And then that would make that go away and that go away, and you would do the dividing. So then you have 10 to the 3x equals 61. Take the log of both sides using the rule log base 10 of k equals k. So we take the log of this side, log of this side. Well, this rule says log base 10 of this equals this. So what it does is get rid of the log and the 10. Okay, so we end up with just 3x by using that rule. 3x equals log 61. Divide by 3. Then you can do that on your calculator. So if we have log 61, close, divided by 3, and we would get 0.595 and probably round it to a certain number of places. All right, so your key was to use this rule. All right, now that was, we had an exponential equation and we had to use that idea of taking a log. What if we have log x equals 2.5? We're going to do the opposite. We're going to exponentiate each side with a base of 10. So we're going to say 10 raised to this is equal to 10 raised to this. All right? And remember that same root. 10 to the log k equals k. So this is gone. We're just left with the x equals 10 to the 2.5. You do this in the calculator and you get your answer. Now, solving exponential equations. Say you had e to the x equals 5. I would suggest taking the natural log of both sides and using this rule. ln of e to the x equals x. So that's what I did here. ln of e to the x equals x. So those are gone. X equals ln 5. That's just a number. Do that on the calculator. So we'll have some practice with our problem set. Let's go ahead and look at those and see how we do. All right. Log base 2 of 32. What you want to think? 2 to what power equals 32? That's an even one, and so 2 to the 5th power is 32. You could use your change of base formula on the calculator if you don't realize that 2 to the 5th is 32, and you could do log 32 divided by log 2. All right. Log base 5 of 25. Oh, I'm sorry, I wrote that wrong. I read that wrong. Log base 25 of 5. So we're saying 25 to what power equals 5? Well, how are you going to go down in number? It's going to be a fractional exponent. So the square root of 25 is 5. That would be 25 to the 1/2. You could still do it with this formula and do log of 5 divided by log of 25. Okay. 5 to what power gives us 625? That's going to be 4. You could do it the same way. Change a base if you need to. Solve e to the x equals 4. All right, so we're going to do e to the x equals 4. All right, remember we're going to take the ln of both sides, and our rule says ln of e to the x equals x. So over here we have x equals ln 4. We're going to do that on the calculator. ln 4 and enter, and it says type an exact answer. I'm sorry, I was reading that one. Round to 4 decimal places, so 1.3863. Okay, I can't get more room there. All right, ln of e to the 8x. Let's get some more room here. All right, ln e to the 8, ln of e to the 8th, type an exact answer. Well, ln of e to anything is the anything, so we don't need to do much work there. The answer is 8. All right, this is the change of base formula again. So that's going to be log of 4096 divided by log of 4. When you do that in the calculator, you should get 6. Make that a little bit bigger. All right, log base 1/4 of 1024. You can do that one in the calculator as well. Log of 1024 divided by log of, you could do 0.25, and you should get -5 when you do that in the calculator. All right, let's look at number 8. And make it a little bit bigger. All right, this one says log base 5 of 5 to the 3rd. So let's think about that. Here's your base. 5 to what power equals this thing? 5 to the 3rd. And that makes it more apparent that your answer has to be 3. Okay. All right, change each equation to its equivalent log form. All right, so we have to remember the following. Base to exponent equals argument. That's the form that we've got, and we want to change it to log base argument equals exponent. All right. So we've got 8 to the 5z equals 5. And we're going to choose this one because our base is not e. So log, and in this box, your base is 8. And your log base 8 of 5z goes here equals the exponent. I'm sorry, did that. So sorry, I was reading it backwards. So 5z equals log base 8 of 5. Okay, because here's your exponent and it's going to be by itself on the other side. So that's the way 5z is going to go there, 8 is going to go here, and 5 will go in the argument position. All right, B part. E to the z equals 2. We're going to choose the ln one because the base is e, and we will have z equals ln of 2. All right. C part, find the equivalent for b to the z equals g. All right, again, we're going to choose the log one because we don't have e as a base, and we are going to have z equals log base b of g. Okay. All right. Number 10. Write as an exponential equation. All right, so now we've got log equations and we're changing to exponential. So here's our base, here's our exponent, and here's our argument. So that changes to 7 to the 6th equals x. All right. Number 11, solve e to the x for 18 equals 18. Remember that we're going to take the natural log of both sides. Ln of e to the x is equal to x. So that equals ln 18. It says round to 4 decimal places. When you do this on the calculator, you should get 2.8904. And remember that you just hit ln and then the 18. Okay. All right, number 12. Solve the equation and use change of base if you need to get a final answer. So we have 9 to the x equals 5. We're going to take ln of both sides. Even though we don't have e, we're going to use this rule. Ln of a to the x equals x ln a. All right, so we're going to do ln 9 to the x equals ln 5. That x can come to the front, and the reason we have to do that, we can't solve for x as long as he's up in the exponent place. We need to get him away or down. So this becomes x ln 9 equals ln 5. X equals ln 5 divided by ln 9. You can do that on your calculator, and you should get, and it says round to the nearest hundredth, you should get 0.73 rounded, because you'll do that just like that in the calculator. All right, 13. All right, 13 says e to the negative x equals 23. So let's write that here. E to the negative x equals 23. Again, we'll take the natural log of both sides. All right, that means we're left with negative x equals ln 23. We'll divide by negative 1, so x equals negative ln 23. And put that in the calculator just like that. You're going to put negative ln 23. Close and enter. And you have negative 3.14, well, 3.135. So we're going to round to the hundredth. And so our answer here will be negative 3.14. All right. Then we have 14. All right, we can rewrite this question with the same base, and that's the easiest way to do this. 10 and 10,000. Well, 10,000 is 10 to the fourth, so we could rewrite that as 10 to the 7x equals 10 to the fourth. All right, if those two things are equal and their bases are the same, it stands to reason that the exponents must be equal. So we can rewrite that again as 7x has to be equal to 4 and solve that. X equals 4 divided by 7. And so that's going to be choice A. All right. And last one is 15. And we're going to do this the same way, except we do have to do a little bit of isolating. Let's subtract the 2 on both sides. So we have e to the x equals 24. And we'll take the ln of both sides. And that leaves x here, and we have ln 24. That's approximately, and we're going to round to the hundredth, 3.18. So I think that should get you through 5.4.